Welcome back to Kamal Kunj Home Academy, Encounter with Physics. In this session, we will discuss about projectile motion. Now suppose a particle is thrown obliquely Suppose a particle is thrown obliquely with an angle theta with the horizontal from the origin O with initial velocity u at an angle theta. Now it goes to maximum height A and then falls at B on the line horizontal to O. Component of velocity along x-axis is u cos theta and component of initial velocity u along y-axis is u sin theta. Here theta is called angle of projection. Theta is called angle of projection u is the initial velocity point A represents maximum height and OB represents horizontal range or simply range. And time taken from O to B along the path OAB is called time of flight. Time taken by the particle going from O to B along the path OAB is called time of flight. Here we have AX acceleration along x-axis is 0. Acceleration along y-axis is minus g if particle going up. And ux vx, velocity along x-axis is u cos theta. It remains constant because velocity is equal to vx is equal to ux plus ax t. Here ax is 0, hence vx is equal to ux is u cos theta. So along x line velocity remains constant. Now horizontal motion, here Vx is constant, that is u cos theta, and x is equal to ux into t plus half t square. Since acceleration is 0, hence this is equal to ux into t, means e into t cos theta. And vertical motion, Vy is equal to Uy minus gt. This is the acceleration due to gravity which is acting on the particle. Since particle is going up, so it will be minus g, acting downward acceleration. This is equal to Uy is u sin theta minus g into t, and distance on y-axis will be Uy into t minus half g into t square. This is equal to Uy u sin theta into t minus half t square. This is a vertical motion. Now let us find the time of flight. Time of flight. At this point, at B, y is 0. So, vertical displacement is y is equal to uy into t plus minus half g into t square. At B, y is equal to 0. Hence, 0 is equal to uy is u sin theta into t minus half g into t square. This implies that t u sin theta minus half g into t equal to 0. This implies that t equal to 0 or t is equal to twice u sin theta by upon g. So t equal to 0 represents the position O. 0 represents the position or that is origin. Hence, time of flight is t is equal to twice u sin theta upon g. This is the time of flight. Now let us find the horizontal range, or simply range. Horizontal range, that is OB. This is equal to u cos theta into time t, time of flight. This is equal to u cos theta and time of flight is twice u sin theta by g. This is the time taken from going to O to B along OAB. So OB is equal to initial velocity and velocity into time. So this is equal to u square twice sin theta into cos theta upon g, and this is equal to u square to sin 2 theta upon g. Because twice sin theta into cos theta is sin 2 theta. Therefore, range is equal to u square sin 2 theta upon g. Now let us find the maximum height reached by the particle, that is this height, maximum height. At this point A, velocity along y-axis is 0. So A y is equal to uy minus g into t. At 0, uy is 0. This implies that 0 is equal to uy is u sin theta minus g into t. This implies that t is equal to u sin theta upon g, and time of flight was twice u sin theta by g, just double of this. It means going to maximum height, time taken by the particle is half of the time taken by the total time taken. So y is equal to uy into t minus half g into t square. This is equal to uy is u sin theta into time minus half g into t square. The time is taken by the particle going to point A is u sin theta upon g. This is equal to u sin theta by u sin theta upon g. This is the time taken by the particle going from A to O to A, minus half g t square u sin theta upon g square. This is equal to UA square sin square theta upon G minus half UA square sin square theta upon G. This is equal to twice UA square sin square theta upon G. This is UA square sin square theta G. Twice G. So this is the maximum height reached by the particle UA square sin square theta upon twice G. Now we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.